Hello and welcome to SudoKanard. We're here to solve this killer exam Sudoku from the instruction booklet of round 1 of WPF Sudoku Grand Prix. This round is organized by India with great authors, 5 of them, and this is a mix of two very common variations on Sudoku that rely on sums. So one of them is killer Sudoku, which means that in such a cage, all digits have to be different and their sum is given in the top left corner. And those outside clues are X-sum clues, which means that this is the sum of the first few digits, and how many digits is given by the first digit here. So for example, this 25 could be the sum of 4 digits with 3. If this is a 4, then this is the sum of 4 digits, and this could be the case. So I put a link in the description to the instruction booklet itself, the website of the event, WPF Sudoku Grand Prix, and also to the pen puzzle, which I will now be solving. So this one can only be the sum of 1 digit. Now 7 can only be the sum of 2 digits, and those will be 2 plus 5, obviously. So that's the easy part at the beginning. 11 now can't be the sum of 2 digits because of this. It can't be the sum of 4 digits because if I try to do this, I need 3 digits summing to 7, and the only way is 1, 2, and 4, and that would repeat the 4. So that's a 3. Those two must sum to 8 without using those digits, so they must be 1 and 7. And actually, 33 can't use 1 here because it would require the remaining 4 cells to sum to 32, and the maximum with 4 cells is 30. So that's the 7, that's the 1. Now this 17, it could be the sum of 4 digits or 5 digits, except that with 5 digits, the remaining 4 digits would have to sum to 12, and that would need to use the 1. Because, well, that's just something that you can easily check. So that has to be the 4. So here we have 4 digits summing to 17, plus that's 28. So the remaining 2 digits must sum to 17, which is 8 and 9. So here we have 2, 5, and 6, and you can check that's 17 indeed. Next place of interest is those lines. I'm focusing on the small sums, the small numbers. So 9 can be the sum of 2 or 3 digits. And 2 digits, it will be 2 plus 7. And you see that actually 2 plus 7 won't work here. And the only other way is with 3 digits. So it will have to be 3 digits, 3, 1, 5 or 3, 2, 4, and because of this, it would be 3, 2, and 4. 10 could be the sum of 4 digits, but 4 is already here, and actually 4 wouldn't work in an 8 cage. So it will have to be either 2 digits with the 3 here, or 3 digits with 1 and 6 here, for example, or 2 and 5. So this now has to be a 6 or a 7. Oh, and that's interesting because the sum of 7 digits can never be less than 28. So this has to be a 6, and that's a 2, and that's an 8. And down there we get the 4 and the 2. And now the sum of 6 digits, 21 is the minimum sum of 6 digits. So those have to be a 3 and a 5. And those are 7, 8, 9. But 9 won't work here because the sum of 9 digits is 45. And would 8 work? If I try to put 8 here, then this becomes a 7. That's possible. If I try to put a 7 here, then those 2 digits must sum to 7. And I don't think it's possible. I'm not sure it's not, so it could still be 5 and 2. So that's 7. Oh no, those 3 digits would need to sum to 26, so that doesn't work. So that has to be an 8. So let me just recap. If this is 7, knowing that the sum of all digits in the column is 45, those digits must sum to 7. 33 needs at least 5 digits. But 8 digits won't work because this would need to be a 12. And 6 won't work because it would need another 6 here. So that can only be a 5. And 4 digits is not enough. So 5 and 2. Oh, actually 2 is not available. So this fixes it. This just clears everything. So 8 digits. The 9th digit must be a 7. So that's a 5. And because this is 7, it means that the remaining 2 digits must sum to 12, so that's a 4. So now 28, we already have 15. The remaining 2 digits must sum to 13, so they must be 4 and 9. Well, it won't be 5 and 8, it won't be 7 and 6. And anyway, because of this, we knew there had to be a 4 among them. Here, this is 1, 6, and 8. 1 won't work here, and there's already an 8 in the column, and 8 wouldn't work anyway. So that the sum of 6 digits here is 26, so the remaining 3 cells should sum to 19, so that's a 9. Here we need 1, 5, and 3. That's not a 3, that's not a 1, so that's a 5. Here we have 22 plus 4, that's 28, so the remaining 2 cells must be 8 and 9. They must sum to 17. Here I need 4, 5, and 6, but that's not a 6, there's already a 6 in the column. Well, 4 and 5, I'm not sure if I can decide right now which option is the correct one. But I see that 25 can't be a 6. It can't be 7. 7 would need a sum of at least 28. So it will also be 4 or 5. Let's have a look at this 10 clue. It could be a 2 with an 8 there. It could be a 3. No, it couldn't be a 3 actually. If I try to make this 3, then I need 2 digits summing to 7. And I see that 1, 6, 3, 4, and 5, 2 are all impossible. So that's never a 3. But it could still be a 4 with a 2 and a 3 there. Actually, yes, I think it would work. This 34 is interesting because the first digits sum to 34, so the last digits sum to 11. And with this, the only way to have a sum of 11 is to take 8 and 3. So that's 1, that's 9. So we need 7 digits to sum to 34. So that's 9, that's 7. And the remaining 4 digits must sum to 10, and the only way to achieve this is to have them be 1, 2, 3, 4. So those are not 3s, that's not a 4, that's not 1, that's not 1. 2 here is not enough for this sum of 14, so that's a 3 or a 4. 4 will never work. If I try to make this a 4, then that's 8 or 9, and those 2 digits must sum to 1 or 2, which is impossible. So that's a 3. And the remaining digits must sum to 11s. With the 4, that would have to be a 7. That wouldn't work. So that's a 2 and that's an 8. And that's 1 and 4. And 8 here. 2, 5, 6 here, but there's a 2 and a 5 here. So that's a 6. So 5, 6, and 9 here, I think. Oh, I put a 0 instead of a 9. That's interesting. That's neither 5 nor 9 because of the rest of the column. And this now can only be a 4. And that's a 5. That's a, oops, that's a 6. Here we need 4 and 7, and I can only assume that this 23 is fulfilled. It is. Here we need a 3 and a 1. There's already a 1 in this column. Where should I look now? This 4. This ambiguates this and that. This 29 sum looks impossible. I did something wrong. Oopsie. Yes. Those two digits must sum to 11, so that's a 9, not an 8. That's 1 and 4. So this is indeed a 6, 2 or 5, that's not a 6. So there was really something wrong in here. So here 5, 6, and 8. That's not 5. And now let's look further. So 5, 6, and 8, so that's must be a 4, that's a 5, that's a 6. Here we have 4 and 7, and it still works, which is some sort of relief. Here that's not the 1, that's the 1, that's the 3. That's 13. To go to 25, we must have 12 here without using those digits. That must be 5 and 7. So that's 5 here, 7 there. 3, 5, no 5 here, so that's the 5, that's the 2. 8 is not here, so it's here. And those are 3 and 9, so 3 here, 9 there. And this 7 makes those 4, 7 in this order, that's 8. Here we need a 9, it must be here, and that's a 7. Up there, that can only be a 1, and that's a 7. And here we get 1 and 8. Right. So now, here we need 4, 9, and 6. So that's 4 or 6, that's 6 or 9. And 2 and 8 is no more possible because of this 8, so that's the 4. 6, 9, 4, and 9, and it works with 1, 2, 3, 4. 3 and 2 here, and that's an 8 to complete the 33. I need the 1 in the column, that's here. Oh, this 8 here removes this option, that's an 8. Here I need a 1, that's the 1. That's the 6, so 5 and 6. Here I get a 3. Those are 2 and 6. So that's a 5, and obviously 2 is not enough for 29. So we just have to, we should check that the sum here is 29. This time I had the prompt, just the pop-up saying that this is good. So I did a real mistake in the middle. It's lucky that I could use the undo shortcut, because on paper those would have been unforgiving, and this is exactly what I do when I solve Sudoku on paper. And this is why I never perform quite as good as I wish I would. Thanks for watching this video. See you soon on SudoKanard.